Welcome back. This is segment 3 of section 1.4, likely our last segment for not only this section, but for this chapter. It does not conclude the course. The course unit will actually include some stuff from chapter 2 for our first unit test, but I mean, that's subject to change. I'm not really sure exactly how the course will be executed from semester to semester, but that's usually my intention is to add some material from chapter 2 as well. So you'll recall that we had developed the 3 Pythagorean identities that relate pairs of functions in a way that's different than the reciprocal identities or the quotient identities. Allows us to kind of cross over a little bit. Now, we had done a problem where we were given a value of a trig function and told which quadrant it was in, then used those identities and did a little bit of algebraic manipulation to find the values of the other trig functions. I don't really necessarily want to go through all of the trig functions again, but I will create a sort of a stripped down problem because it's the same problem just in a different light. So let me kick over here and I'll kind of state the problem that I'm wanting to cover. So this is section, I'm sorry. So section 1.4, I believe we're now on page 5. So suppose cosine of some angle is equal to negative root 2 over 3. And, sorry. Oh, I don't know. Pick any other function you want that's not the reciprocal. Let's say, and tangent of theta is greater than 0. Find sine of theta and tangent of theta. And that'll keep it a little simple. Because once you have sine, cosine, and tangent, you know, the other ones are just the reciprocals. It's not anything new. So here's what is new, is that we now have, instead of the problem telling us which quadrant it's in, we have to sort of figure it out, right? So here's the question that we ask ourselves. From this statement, cosine is negative. Cosine is negative in quadrant 2 or quadrant 3. 2 or quadrant 3. Tangent, on the other hand, is positive. We don't know its value. That's part of the problem here. But we know it's positive, and tangent is only positive in quadrant 1 and 3. So we have 2 and 3, 1 and 3. What we're looking for is the overlap, and that happens in quadrant 3. So between these 2 bits of information, the sine on cosine and the sine on tangent, we know that theta is in quadrant 3. Now, we already know the SIGN of tangent. We have the value of cosine. What this is really used to tell us is that sine of theta, because it's in quadrant 3, is negative, okay? And that's really the only reason why we use that. So what's the strategy to move forward? Well, we don't really have any equations that relate cosine to tangent directly. So we'll probably need to use an equation that relates sine to cosine. And that's easy enough to do. We did it last time. We had sine squared of theta plus cosine squared of theta. Remember, this is the first Pythagorean identity, equals 1. I don't want you to think that the other 2 aren't important, but it just so happens that this is the one that people remember most easily, and these are really the 3 most important functions anyways. Okay, so sine squared plus cosine squared equal to 1. So sine squared of theta is equal to 1 minus cosine squared of theta. Again, we're going to take square root both sides, kind of some shorthand over there, SRVS, or maybe TSRVS, whatever. So remember, it is going to be plus or minus, right? Plus or minus. We'll know which one it is based on this, but algebraically speaking, if this is true, then you have to include this plus or minus to keep a true statement. So plus or minus the square root of 1 minus cosine squared of theta. Now, because it's quadrant 3, and we've already determined that the sign is, that the SIGN of SINE is less than 0, we can get rid of the positive branch. So we have sine of theta is actually the negative square root of 1 minus cosine squared of theta. Now, substituting in the value that we have for cosine of theta, we have that this is the negative square root of 1 minus negative square root of 2 over 3 squared, right? And when you square this, that negative sign will be stripped, but there's this one that's sitting on here, so this becomes 4 over 9. This is 9 over 9, but minus square root of 9 over 9 minus 4 over 9, which equals the negative square root of 5 over 9, which equals the negative square root of 5 over 3, right? So we had negative 2, negative square root of 2 over 3. We also have negative square root of 5 over 3. Interesting. So what does that tell us about tangent? Well, tangent of theta is equal to, just like we did before, sine of theta over cosine of theta, which happens to be equal to, let's go down here, happens to be equal to the negative square root of 5 over 3 over negative square root of 2 over 3, which equals positive square root of 5 over square root of 2. Now, to kind of fix this business, we need to multiply by square root of 2 over square root of 2. And remember, when you multiply radicals together, they stay inside the radical. So this ends up being positive square root of 10 over 2, and that's simplified. So achieving the problem we asked for, we started with cosine and some information about the quadrant. Through this manipulation, we end up with the value of cosine, negative square root of 5 over 3. And with another fundamental identity, we find the tangent. Now, what you could do is just check, because if we made some sort of arithmetic error, you might have an SIGN error that's easy to check. Tangent has to be positive. And notice that's exactly what we ended up with. So this looks like good stuff. Okay, so I know I did that one quick, but we did one that was very, very similar, so I'm not too concerned about that. We could do another one maybe that uses some of these some other identities. I don't know that it's really useful. I want you to practice this stuff. So if I did them all for you, it might give you the sense that this is too easy. So that when you do the homework, there's several different opportunities to do this kind of stuff. Take those exercises seriously, because there may be something on the test that looks something exactly like this, where it's just, maybe not the exact numbers or whatever, but it's the same sort of setup. Okay, so with that stated, there's really only one other thing that I want to talk about that happens in section 1.4, which is these kind of oddball problems that they seem completely out of place here, where you've got something that looks, it looks something like this, where you've got find theta given secant of 2 theta plus 6 degrees equal to 1 over cosine of 5 theta plus 3 degrees. This is just kind of out of left field. You're like, when did this happen? And it turns out that there is more than one answer to this problem. And we will never have a problem that is find all. Well, we might have a problem where you're supposed to find all of the solutions, but that would be sort of the very end of this course. That's why I feel like this is kind of out of place, because what they're really asking you to do is to make the connection between these two trigonometric functions and their associated fundamental identity. So here's sort of, when you see this sort of setup, the first thing to do is to either, well, probably make the substitution here. 1 over cosine of something is equal to secant of that something. So the very next step, you have that secant of 2 theta plus 6 degrees is equal to secant of 5 theta plus 3 degrees. Now, I'm just telling you that in chapters, I mean, we don't necessarily do these, but things similar to this, in chapter 6, we will discover that there are actually 20 different possible solutions for this equation, and potentially 20 different equations that occur just between 0 and 360 degrees, right? That's kind of a little weird. I mean, to be tackled with that problem right up front. But one of them is really, really easy to find, because it is certainly the case that if f of x equals f of y, right? So basically we've got a function of something is equal to the same function of another thing, right? If f of x equal to f of y, then it is certainly the case one solution is x equal y. It's not necessarily the only solution, but it is one of them. And so when this question is asking you, find, given, not given theta, given, well, whatever. So the critical step here is really right here, recognizing that this fundamental identity allows you to have function of x plus equal to function of y, and then you can make this little step. So from with this sort of understanding of what happens here, we can go straight to 2 theta plus 6 degrees is equal to 5 theta plus 3 degrees. It is one solution. It is not all the solutions. So this now becomes an algebra problem. You can solve it pretty quickly. 3 degrees is equal to 3 theta, and so theta is equal to 1 degree. So it seems like it's, like I said, it's really kind of out of place, but it is something to kind of get you thinking about sort of the long term, what this whole process is about, because this is the kind of thing that you're wanting to do at the end of the course. And so at least it's kind of got you there, considering those possibilities sort of up front. I think there might be some others, and if you find some that you really just can't figure out, you're free to ask me about them when we have our sort of open sessions to review the homework problems. So with that, this is the end of not only section 1.4, but also the end of chapter 1. I will see you again in chapter